Hi everyone. So today I'm answering the question, what is the speed of light? So you may have heard of the term speed of light before, but maybe you don't know what it is. But it's actually really simple. It is actually as what it says it is. It's the speed at which light travels, specifically kind of in a vacuum. So a vacuum is a volume of space that has no sort of particles, no air or solid or water or anything inside it. So outer space is a vacuum because there's basically no particles in it. But anyway, that's not important. It's the speed at which light travels. And it's so important because it's the fastest speed that anything in the universe can travel. Nothing can travel faster than the speed of light. So there's some proofs and some derivations as to why this is the case. And basically it comes out that as you get closer and closer to the speed of light, if you're moving something with some kind of mass, some kind of particle, or even me or you or a table or whatever, if you try and make these go the speed of light, travel at the speed of light, then you need more and more energy to get there. And it gets to the point where if you're actually travelling at the speed of light, you need an infinite amount of energy, which basically isn't possible. So that's just why the speed of light is so important. It's the fastest that anything in the universe can travel. Now the speed of light is 300 million meters per second, which is really fast, obviously. So it's a huge speed. To put it in example for you, Usain Bolt runs at like 12 meters per second, right? So 12 meters per second is the fastest that a human being can basically run. The fastest car is around 121 meters per second, so about 10 times faster than Usain Bolt. Okay, it's just getting a bit faster now. The shuttle as it orbits around the Earth is like nearly 8,000 meters per second. Right, this is a space shuttle. This is one of the fastest rockets we can get, and it's going around the Earth at about 8,000 meters per second. Well, again, the speed of light is 300 million. So this is the real scale. There's a massive jump. And obviously there are other things that go faster than the space shuttle, but the speed of light is a huge speed. I mean, we can get nowhere near the speed of light kind of travel. Now, because the speed of light is a certain speed, light doesn't travel from here to here instantaneously. I mean, even between my two fingers, it will take a fraction of a second for the light to travel between the two. If I get a torch and I turn it on now, I would actually see the light from the torch turning on before you would see it in the camera. I mean, it's really small, and it's just a tiny amount of time, but still there is a delay there. But what this means is that, for example, you might know that light from the sun takes 8 minutes or so to reach us down here on Earth. So we're actually seeing what the sun looked like 8 minutes ago, because we're seeing the light from it that was emitted 8 minutes ago. So this means if the sun exploded at this very second, we actually wouldn't see it exploding for 8 minutes, which would be really weird. I mean, the sun has actually physically exploded and it's gone or whatever, but we wouldn't actually see it happen until 8 minutes time, which is particularly odd. For another example is that the light from the nearest star other than the sun to the Earth takes about 4 years to reach us here on Earth. So when we look at this star, we're actually seeing what it looked like 4 years ago. So, many of the, and this goes all the way through, so the further and further objects are away from us, the more longer we're seeing the light from them. So if they've been, they've exploded, or the stars have died, or galaxies have collided, and they're millions of light years away, then we're only seeing what they look like a million years ago. So by now they're really different. They might not be there, but we're still seeing what they look like millions or thousands of years ago. So this is what the speed of light is. It's literally just the speed at which light travels, but it's really fundamental because it's the fastest that anything in the universe can travel. And so it sort of gives us a fundamental upper limit on lots of different things, astrophysics, particle physics, all things like this. Thank you very much for watching. I hope this made some sense to you and you kind of know what the speed of light is now. It's pretty simple, and this is a nice little easy video, but it's kind of important that you understand what the speed of light is and you know what the speed of light is, and it's really interesting as well. Don't forget, like, subscribe, follow me on Twitter. Thank you very much for watching, and I'll see you guys soon.